A and scenario B. Did you send me? All right. Let, yeah. Let me see. Yes, exactly. I think -8, -8. That is on the. Okay. So you draw this 2y plus 8 is equal to x and 4y negative 2x is equal to -16. That one. This is scenario B. All right. So there is no two different lines, right? Is it the same line that this red color line? It's two. Okay, so I don't need this one. I need to see your equation that you wrote on the Desmos. Show me that equation, or just check it from your end also. Like it is, yeah. Just check. Yeah. So it. All right. Great. Coming to the third scenario, the C, 6x is equal to 20 minus 2y. What happens with the third scenario? Yes. So it means it have no common point of intersection, right? There is no solution for that. So now you have the three scenarios. You can see one in which you have one intersecting point, the B where you have infinite points common because these two lines are nothing but the same. One is the multiplier of other, right? The coincident lines. And the third is the parallel one. They're not going to intersect anyway. So if no intersection, then there is no common solution, right? Now come to the question 2. How many solutions does each linear systems have? Explain your answer. You know the things here? Is it clear? The question number 2? All right. What are you going to answer for the third one? Okay. Research the names. Research the name used to classify the three types of linear system. So you're going to do the research. Okay, so just uh, take this question down and do R&D from your end, like what be call two lines when intersect at one point, coincident line and the parallel line. Okay. Mm-hmm. Yeah. Okay. Intersecting lines. Okay. See, I'm telling you, system of equations, you can write it down. System of equations can be classified by the number of solution, by the number of solutions. If the system has at least one solution, at least one, then it is says to be consistent. So this one is consistent. If the consistent system has exactly one solution, then it is known as independent. And if the consistent solution has infinite number of solutions, then it is called dependent. I think I just refer the wrong one. This will be known as, when there is no solution, this is known as inconsistent. This is known as inconsistent. When you have no solution, right? So inconsistent system has no solution, basically when they are parallel. These both are known as consistent, basically when they have some kind of solution, whether one or more than one, both are consistent, right? But out of that consistent, we have infinite solution, that is known as dependent. Dependent system. This is dependent system. And the what is the independent system? Independent system is one which have exactly one solution, right? So these are the name based on the number of solution. Independent system, dependent system, but these both are a consistent one when they have the solution, inconsistent one when they have no solution. Okay. One solution. Infinite many solution. Inconsistent when you have no solution. All right. Coming to the question where you have to is it possible to determine how the line will intersect before actually trying to find the solution by graphing? Rewrite all the above equation in the form of y is equal to mx plus c and copy and complete the table below. So what do you need to do? You need to find y is equal to mx plus c of B and C technically, because A already have their y is equal to mx plus c equation, right? A, B already have y is equal to mx plus c. So here it is 2x plus 1, and there another y is equal to negative x plus 7. So what is the slope of each line? Talking about line 1, the slope is what? Slope is 2, isn't it? And talking about line 2, the slope is negative 1, isn't it? Yeah. Now, talking about the y-intercept. What is the y-intercept in y is equal to mx plus c? C is the C is the y-intercept. Remember, I told you for C1, yeah, so line 1 it is 1, and for line 2 it is 7. Number of solution, we already know, 1. Okay, number of solution is 1. Okay, we already did that through the graph. Now, you can do this for the B, change that into y as a subject, change that into y is equal to mx plus c, right? For both of the line, find the slope, find the y-intercept. Number of solution we already know. Number of solution we already know. For the B is was infinite. Infinite solution. Mhm. So that is the very basic rule of changing the position of one entity from one side to other side. If you crossing that boundary of equal to sign of any quantity, whether it is variable or whether it is a number, you need to change the sign, right? Mhm. So we still need to do some work here. It's not completed. 2y is equal to x minus 8. But we need to free the y from coefficient. We not need to want any number with the y. So I need to divide every term with the 2. So what is happening here? Y is equal to 1 by 2x minus 4. Yes, that's what I'm telling. Yeah, that's what I'm telling. They are exactly the same line, but due to different multiplier, they looks different. But when you change that into the gradient intercept form, y is equal to mx plus c, you actually peel off the color, right? You just peel off the skin and just you see, okay, these are exactly the same line, and that's why they are overlapping, right? So M1 is 1 by 2, M2 is 1 by 2, C1 is negative 4, C2 is negative 4, right? For the C, we have no solution, number of solution, no solution. Yes, what is the y is equal to mx plus c for the C part 1, the line 1 and line 2? No issue. So it is, yes, that is the line 2, y is equal to negative 3x positive 5. What about line 1? Yes. So y is equal to negative 3x plus 10. Y is equal to negative 3x plus 10. Right. So what is the M1 here? M1 is negative 3. M2 is negative 3. Right. When they have the same slope, when they have the same slope, the condition is they are parallel line or they are the coincident line. It means one lying over another. But you can see the difference in B and C. Where is the difference? Difference in y-intercept. So the y-intercept of line 1 of C is 10 and y-intercept of line 2 of C is 5. Right? But what happens in the coincident line which overlapping? Both of the y-intercept exactly same. Slope is exactly same. They are exactly the same line. But in C, slope is same. It means their alignment with the x-axis is same, but they are not the same line because they have the different y-intercept. Right? So it means they are the parallel line and the parallel line have no common solution. Are you getting this? All right, great.